Forward your intro. No, I just did it. Thank you very much. It's a pleasure to be here. I appreciate it. All right. I get, by far, the biggest question I get when I'm at conferences is when sort of people look at what's going on at Amazon, they ask, why Amazon? And like, what's unique to Amazon? Or what are you doing different? Like, what's the special sauce? Because when you look at other companies of similar size and similar spaces, you really don't see the adoption of formal methods that you see in Amazon. And so I'm going to try and answer that today. That's basically the point of this talk. Okay, and we're going to talk a little bit about kind of what's been going on, but there's so much stuff going on, it's actually kind of hard to summarize it. So I'm kind of going to talk about what's going on as an exercise of talking about why Amazon and why Amazon has been investing in the space. So what's kind of motivating that question is, I'll just give you sort of a very short laundry list of some of the things that are happening. So there's this thing called VPC. These are all customer-facing features. So VPC Reachability Analyzer, Managed Config Rules, S3 Block Public Access, IAM Access Analyzer, and then lots of open source code. So for example, this recently open source differential privacy library that's been proved correct. Big piece of improved correct in Lean Theorem Prover. And then we look at like the internals of AWS. Basically, every piece of AWS these days is in some way impacted by formal methods. So these ones are directly impacted. So we'll talk just about a few of them. So there's a proved correct policy interpreter, for example. So AWS gets called 2 billion times per second right now. When you call AWS, like making a cloud API call, there's a principal, there's a resource, and then there's an action that's being taken. And what AWS does 2 billion times per second is it collects up all the resources related to the principal and the resource, and it makes a decision about whether or not it will allow that action to be taken. So a bug in that policy interpreter would be very, very bad news. And so we've rewritten that code actually in Daphne and proved it correct. So that's an example. Reasoning about pricing models, reasoning about our internal networks, both the actual low-level networking gear, but also virtualized networks, and so on. And then basically, I mean, every service uses cryptography, so we've done extensive work in cryptography. So here, for example, are is a sort of an idea of some papers. Every service uses networking. Every service uses storage. So in a sense, when you're building within AWS, or if you're a customer and you're building on AWS building blocks, there's been extensive proof on that, and so thus every service in some sense is benefiting from that work. So I'm just, there's just been like tremendous, it's very important to customers, it's very important to the executives. So here, for example, is Peter DeSantis, who runs all of AWS engineering, talking about automated reasoning in front of big crowds. And then, just sort of laundry lists of executives. I'm just trying to give you the idea of how important this is to the leadership of AWS. Okay, and so there's an interview with me and the CTO entirely on formal methods. Here's a talk by the most senior, most influential individual contributor. So he's a distinguished engineer of security, giving a talk that's entirely based on all about formal methods. And then here's another one. This is the VP of head of compliance, the team that helps do the audits of AWS for governments, with the CEO of one of our third-party auditors, again, talking about formal methods. So you get the idea. So that's kind of what's going on. So what I wanted to do, so what there's a lot of stuff going on, and I could talk about it for hours and hours and hours. But what I've tried to do is to boil down into 4 things I think are really important about why we've been successful at Amazon, and I wanted to talk to you about them. So these are the sort of 4 key concepts I think that are quite interesting. While I would love for you all to come join Amazon, and my talk will end with an advertisement for jobs. I'm a realistic person, and I'm going to assume that many of you will go to university, many of you will go do startups, many of you will go to other companies, et cetera. And so, as a formal methods person, I'm not sure that not all of these things will adapt, but I wanted to have a discussion such that you could kind of understand what went well. such that maybe you could integrate some of those ideas into the companies you form or the organizations you join. And ultimately, I mean, some of you folks have been around for a long time. Some of you are new to the field. So for those of you who are younger, as you sort of make career choices and as you grow in your career and you begin to lead organizations, maybe some of the things I'm saying now will help you and influence kind of how you think about things. So the goals are, you know, find models that can be like what went well and how like what things could we learn and take outside of Amazon. Thoughts for students, thoughts for academics sending people to Amazon. Like if you're a professor, then probably you have students and maybe some of them are considering roles with us. And then thoughts about for people who are collaborating with us. My goal is not for this to be a marketing Amazon talk, though I mean, you know, ultimately it will be, right? But I don't want it to be. Okay, and then time permitting, I have a slide on some open challenges. Okay, so let's get started. So the first, this is sort of a standard business concept, but Amazon turns it a little bit on its head. And so I wanted to kind of walk you through this. There's this, it's the idea of the virtuous cycle. It's actually, there's this very nice talk by Jeff Bezos at MIT long ago, before he got buff, where he's talking about this idea. And so the idea is basically like take customer experience, right? So if you have a good customer experience, you're going to have more traffic, more people are going to come to your website. The more people you have on the website, the more you're going to be able to get third-party sellers. The more third-party sellers you can get onto Amazon, the more selection you're going to have. The more selection you get, the more better customer experience. There's you know, that's the assumption of capitalism, right? That choice is a good thing. So we'll sort of leave that as an axiom for now. And then better customer experience, you have more traffic. And so that you tend to see this growth, right? And then the idea is, well, as you hit economies of scale, there's all kinds of things you can do that you couldn't do before. So there's a way of taking your growth, using size to your advantage, and then lowering your cost structure, and then thus you can lower prices. And if you lower prices, you feed it back into the customer experience. So that's kind of the idea of Amazon. So Amazon leaders are really looking for these virtuous cycles. So an example of this, there's a nice talk from, so Andy Jassy, who's now the CEO of Amazon, but he was for a long time the CEO of AWS. There's a talk at UW where he tells the story about AWS is an example. So what happened in Amazon is they built basically the components. They were thinking about building these components for internal use. And then they thought, if we launch these externally and get lots of other people using them, that will allow the service to get much bigger, which will change the economies of scale, and then we can begin to invest in the underlying structure, right? So, so it was really like a refactor of its internals, and they figured out how to externalize it for scale. So the thing that's a little weird, and it took me a little bit of time getting used to, definitely coming from, I have some former Microsoft colleagues here, so maybe this will be familiar to them. I always thought being at a high profit margin company was a great thing, right? And what much to my surprise, is being at a, so what Amazon is trying to do is they're trying to be a high volume company. They want low profit margins, because if you have low profit margins, it's cheaper, more customers will come to it, and then they get more scale, and with more scale, they can actually continue that flywheel. And there's going to be some weird consequences for that. I promise you this is going to get back into, this is not a business lecture, right? There is a connection to formal methods, but bear with me for a second. So if you look at Amazon's profit margins, this is a couple of years old now, really it's more like CVS or Walmart, as opposed to some of these other companies that you would think are more like Amazon. Okay, so why is this interesting from a formal methods perspective? Okay, so in this world, if you sort of acknowledge that we're going to be a low profit margin business, what you're going to do is you're going to try and launch stuff super fast, get lots of people using it, get as big as you can, then figure out how to refactor it, right? Because you're going to now start lowering costs. You're going to lower costs to get more customers on it. You're going to learn what they do, figure out how they use it, keep iterating. So basically, they're constantly rewriting this code, and this is kind of where formal methods comes in. What they want is agility. They want to constantly rebuild the infrastructure, and that's where formal methods comes in. So here, for example, S3 completely rewrote big pieces of the stack, right? And they're trying to drive down cost, but that's also where formal methods comes in. The formal methods allows them to move a lot faster. Okay, another example. So AWS in the early days was basically like, commodity hardware, Linux, Xen hypervisor, OpenSSL, land, credit card, growing, right? That was EC2. And then they built the business, and then they thought, oh, how can we refactor this for increased security, lower cost, lower energy consumption, et cetera. And they ended up rebuilding the entire stack. They've ultimately rebuilt their own hypervisor, their own hardware, their own networking gear, everything's custom. And they did that for cost, security, and they did it with formal methods. And so this talk is, first time I gave this was a couple years ago, so I should probably update it. There's like massive, extensive work now going on in EC2 and storage and more papers and really exciting work going on in this space. So that's the idea. So we're basically trying to lower cost and increase agility for the organization. So it's in line with the business. I guess that's kind of the thing I'm trying to say, right? Is that there's a huge business need, and we can provide better security. More customers are interested in coming to AWS because they appreciate the security story. They appreciate lower cost, and we're able to offer that lower cost because we're using formal methods, and then it accelerates. These things are also composable, by the way, so you can put them together. And so this is how Amazon people think about them, right? Is that you have like these virtuous cycle. Each business group is sort of its own virtuous cycle, and they're connected up, and they're helping each other out. So for example, KMS, any proof we do on KMS helps S3 because S3 uses KMS. For example, KMS is the key management store. So there's a paper out, for example, about KMS. Okay, so then the other really amazing thing is because Amazon has, every team is kind of considers itself a little bit of a startup, they have sort of similar stresses and needs. And so what we've seen in Amazon is we get success with one of these organizations, and then the other organizations see that they're getting success, seeing that they're able to lower their cost, that more customers are coming to AWS because of the work, and then more people copy it. So we're basically seeing viral spread of the ideas of using formal methods. And so teams who aren't doing formal methods now are trying to get time on my calendar, trying to like figure out how to use this stuff because they like what they see watching the others. I'll say one other thing that what's kind of interesting is that science accelerates this, right? So as a scientist, you can pull the traffic off, do science, improve the technology, and that also increases that scale. So that's very exciting. So basically, these days, like every day for us is like SMT comp, right? We're getting a huge flow of traffic of formulae and programs to prove, and that drives the science, and that's very, very exciting. And so that's where I think things are beginning to get very historic. So I'll give you an example of something I find very historic and amazing. Hold up your hand if you know about Malab Mono.
I learned about it yesterday.
So ignore the top black line. This is the past 20 years of stat solving, right? All the winners of the international stat competition for the past 20 years compared apples to apples, same hardware, same benchmarks. And the black line on the top is this tool called Malab Mono. So it's the stat solver that, if you look at the difference, it's like better than 20 years of research. And the only difference between the other solvers and the black line is that the black line is a distributed solver. So it's using many copies of stat solvers, and conflict clauses are being shared across the network. And then all the other solvers are sequential, run on sequential microprocessors. And so it turns out that these things are really hard to operate. It's hard to operate a distributed system, but that's what AWS does. And so what's really amazing within AWS is we're beginning to build these like distributed, program reasoning, SMT solving, stat solving, lean, like deductive theorem proving tools, and we're beginning to use these huge distributed algorithms that just one couldn't even have imagined. And we're able to do it because we're able to measure it, and we know we have a business problem, and if we do it really well, it makes Amazon move faster, and that's great. So we're beginning to build the kinds of infrastructure that just are kind of mind-blowing. So watch this space for research. Okay, so that's the first bullet point, right? So the virtuous cycle model. So I'm going to go through 3 more about this pace. Okay. Okay, so let's talk about working backwards. It's hard to talk about problems at Microsoft Research with my former boss's boss in the room from Microsoft Research. We'll be very careful here. But past labs that will remain nameless have not been obsessed about that. I'm going to say something very controversial. That the lack of obsession about the problem you're solving as opposed to the technology you're building ultimately harms the funding models and ultimately the progress in that field. And that is taking me a lot. And you may not everyone. There will not be uniform agreement. I'm sure a lot of people in the room will disagree, but this has been my experience, and I'm sticking with the story. And so I'm going to kind of explain why a little bit. So what happens is you get this virtuous cycle imbalance. You focus on the technology, but you don't focus on the results. And so the results don't get to the customer experience, and then the customer experience doesn't drive the traffic, and then you can't get the technology funded. So you kind of keep working in your small team with the technology, whereas if you kind of focused on the application and the results, counterintuitively, suddenly you get way more funding, and if you get way more funding, they'll build big teams who'll build big pieces of infrastructure, and then you can focus just on the technology. So just about the time you kind of like say, well, I'm not gonna be obsessed about the technology and how all the details work, but I'm gonna work on the application and make sure that I'm getting like the application working well. Just around that time you have success, then suddenly big things are formed, and you find the only thing you can do that's really differentiating is to work on the technology. So that's kind of what's happened to me in my career, and so that's kind of what Amazon has taught me a little bit. So otherwise you have this sort of virtuous cycle imbalance. The funding isn't there, you don't really have access to the data, and ultimately this sort of things sort of stagnate. That's my experience anyways. So I'm not saying that, so this idea of curiosity-driven research versus customer-driven research, right? And Amazon is a little bit more on the tip of customer-driven research. And so I'm not saying that it's not without value, but you have to have balance. So I like this quote a lot. That the test of intelligence is the ability to hold opposed ideas in your mind and make progress. So I'm making the point that there needs to be balance between the application and the ivory tower, I don't want to be bothered by reality kind of dream that many of us have or have had in the past. Okay. Do you know this quote by Strachey? Hold up your hand if you know it. So I'm going to paraphrase it for you. Basically, the division between theory and practice in our field is injurious. That theoreticians don't know what to work on, and practitioners don't know what they're doing. Right? Like you find often when you're in industry that people are kind of just doing stuff, and you're like, but wait a minute, isn't that like there's just all kinds of theoretical things they don't understand. And there's all these tools that sort of use theory that are really powerful that they don't understand. But meanwhile, when you talk to theoreticians, they have these amazing tools, but they kind of don't know what to do with them. They don't know which, like when you're working on undecidable problems, you need to be even closer to the customer than normal, right? Because the only way you can't solve it in general. So you have to find some niche applications and go for that. But to do that, you have to talk to the customer and understand what the customer needs. And so there's traditionally in formal methods field, there's been a little bit of a, no, I'm a researcher, I don't get my hands dirty, I'm sort of thinking about this deep thing. But that kind of counterintuitively means that you're actually not out of your comfort zone, and thus you're not kind of discovering the big theorem that needs to get proved. I mean, I'm overstating it. I'm sure people in the room will disagree with me, but there you go. So Amazon, one of the things I think they do well, and this is one of the things to think about for yourself, Amazon has all these mechanisms because they know a lot of us coming into the company, and non-formal methods people too, like people in engineering, come into the company and they're tech obsessed. They want to work on the tech. They're interested in the tech. And Amazon is trying to pull them, kicking and screaming, into the world of thinking about what the application is. And so they have this thing called the working backwards process, which is really important. So they know that we're obsessed about the technology, and they're trying to drive balance, right? So basically, there's this idea of a press. Basically, the first thing you do, and Oksana, who's in the room, has worked at Amazon. There's a couple of people at Amazon, I think, will confirm that very quickly when you're starting up a project, the first thing you do is you write the press release that you will send to the New York Times when you're done. And you actually spend a lot of time shopping that around. You go to different teams, and you're kind of trying to get everyone on board about what you're trying to do with this press release. And you iterate on the press release. And so most projects I know have had like hundreds of revisions, hundreds of meetings, lots of debate about that idea, but you're kind of trying to get there's the press release and then there's the frequently asked questions. And most meetings in Amazon begin with 20 minutes of silence because most meetings in Amazon begin with everyone reading the document. So you'll start the meeting, you put the press release available for people read for 20 minutes, and then they discuss. And so that what they're trying to do is they're trying to get you to not think about the tech as much, but to think about what the value of the tech is going to be, and that's why they call it the working backwards process. Trying to drive consensus about why, and then that interpolates the work of the value of the work. And that pushes you out of your comfort zone. So there's a bunch of work that we've done that I would have never occurred to me because it came out of this press release process. There's another point I wanted to make. So Oksana was mentioning, we actually have, I don't know how many teams, 15 teams doing formal, like in the hardware, the networking, the storage, the crypto, identity, security, you name it. And they're all in different organizations, but we all collaborate together quite a bit. How is it that works out? Well, it's actually the working backwards process, right? So here I've got two representatives, Amina and Leo Demora. So maybe you know, Leo Demora does the lean theorem prover, for example. So Leo's in one team, Amina's in another team. Amina's a customer of Leo. So when Leo's thinking about doing some new stuff in the lean theorem prover, what he's doing, and I was actually in a review with him pretty recently, he's writing a press release around what is this thing going to be. And then we read that with someone like Amina. And then Amina is like, well, that's not quite what we need. And we kind of iterate. And then after we've sort of got a bunch of the stakeholders aligned, then we go and code. And so the time spent coding is much better spent that way. And it maintains collaboration across this, a large organization with, tens of thousands of people. Okay, I think I said all that. I think I made that point. Good. So, right. So why has Amazon been so successful at formal methods? I think one of the things is this working backwards process, and that connects to this idea of the virtuous cycle, right? Every time you build something, you end up building consensus across a large organization, building the right thing, and that drives, better selection of, sorry, wrong word. It drives better tech that then accelerates this thing, and thus things grow, and thus you can get stuff funded. I think it's the way to say it. So the next one is this idea of continuous delivery model. So Amazon pushes for continuous improvement rather than moonshots. I'm going to describe what that means. So the idea is like, don't let get perfect be the enemy of the good. In formal methods, this is a very unusual view, if you think about it, right? So Dijkstra is like, if you've written V2 of the program, you didn't write it right. That's not the view Amazon takes at all. Amazon's view is, let's launch something super fast and get it in your hands, and then you're going to do weird things with it that we didn't think of. So let's watch what you do. Let's get telemetry on how you're doing it. Let's come to interview you, talk to all the people in your organization who are using it, and learn what you're doing with it, and then iterate really quickly on what it is we're launching. In certain sectors of the formal methods world, that's a really unusual way of seeing the world. Other sectors, it's actually quite normal, right? So that's what's going on in the SAT SMT community, where they're like, we're never actually going to solve the problem, so why don't we just chip away at it forever, right? And they're sort of competing with each other and like making small changes. So Amazon has much more of a feeling of this world rather than this world. So the advice I got when I first joined Amazon is like, when I first joined, I'm like, hey, I'm going to build the world's theorem prover. And they're like, whoa, slow down. They were like, why don't you build a ladder, right? A moonshot ladder. And so they're basically saying each rung, like do something such that every 3 months or every 6 months, you deliver something new that actually has value, that people can talk about, people can use. And that's turned out to be really great advice. So for example, I'll use the example, there's one of the tools we have is reasons about the semantics of the policy language. So you can write a policy and you can ask questions about it at the semantic level, and it's ultimately a reduction to SMT solvers. So the first thing we did is we made this tool that was very hard to use, but we had a bunch of like high-end, particularly New York-based financial services companies began using it because I went to lunch with them. basically. And so Bridgewater Associates, that's the world's largest hedge fund, Goldman Sachs, et cetera, began using this tool super, super early. And they made a bunch of comments about it, right? And so that tool is called Zelkova. Ultimately, so here's some talks they gave about using it before there was this product called IM Access Analyzer. And I think maybe you were there, like maybe at Netflix, you were in that team. But I think it was with this tool, you were at Netflix, and Netflix said something that in the parking lot, you were all like, oh, now we get it. Now we know what the product is. IM Access Analyzer, and it was like a concept of a parameter or something. It was like a property you could check, and they were like, that's the product. So then they went and built the product, right? And so then customers were even more excited about it, right? And so then we launched this thing called IM Access Analyzer. It was a really big deal. Here's a bunch of customers and industry folks at Amazon's annual conference for the cloud, learning all about it. And then, lots of people using it and loving it. And then ultimately, that spec, the thing that, Oksana was on the team that wrote the spec of what is the semantics of the AWS policy language, that was the thing that we've proved later. So now when I say, oh, there's this program that interprets the policies and we proved it correct, we proved it correct with respect to that specification. Okay, a few other thoughts on this one. So something that I think Amazon does really well is they like to move really fast, but then they also like to learn mistakes and broadcast those mistakes widely across the company. So we have a process called the COE process. So whenever something goes horribly wrong, we take a moment and we write a paper about why it went wrong, and then we publish it, and it's published across the mailing list. So you can join, anyone in the Amazon can join this mailing list and see the things that went wrong. And so from a formal methods perspective, I think of it as like stat solvers, right? Stat solvers they make some random choices. They get to places that are unsatisfiable. They learn conflict clauses. They put that conflict clause in a database that's very easy to read, very fast to read, and then they keep doing it, and they do restarts, right? And that's precisely what Amazon is doing. They're like, don't overthink it, just go. But then when things go horribly wrong, let's learn why, let's record that, let's distribute that information. And so a lot of people, when they're trying to propose a new tool or product or project, they'll use that database of things that went wrong in the past as evidence as to why this is a really good idea to do. So that's an idea that you might be able to take with you, right? And so what ultimately happens, I was talking about this continuous deployment, this idea of doing things continuously, is that you end up going to really surprising places. So here this is a picture of Mars, not the moon, right? So you're like, I want to go to Mars, I want to go to the moon. Oh, well, why don't you deliver towards the moon? But every time you deliver something, let's look at it and let's do a new press release for the new feature that's going to be the next rung in the ladder, and we'll do that continuously. And what you'll find is you go into different places. And that leads you to all kinds of surprising things. So these are papers that we wrote that I would have never thought of because of that process. Another thing I wanted to say, I did not expect. Enterprise, security-obsessed, regulated customers and executives in Amazon love soundness. They don't love bug finding, they love soundness. You can't go to a customer and be like, hey, good news, we found 10,000 more bugs, right? They're like, wait, why am I using AWS if you're finding all these bugs, right? But you can go to them and you can say, hey, good news. We didn't prove everything about the system, but we did prove this property. And this property is proved under these assumptions, and now we're using the penetration testing team to go after those assumptions. We're assuming the Java garbage collector is correct. We're assuming the microprocessor is correct. We're assuming some stuff about the network. But under those assumptions, this holds. This is true. And they're like mind-blowing. They're like, that's why I'm moving my data to the cloud. And so we began to hear that from customers. They're like, and you kind of see this in large organizations, that the hands-on keyboard developers love bugs, right? Because they don't see the global picture. They're just like, find the bugs that are like, so I don't have to be up at night debugging the system when there's an outage. But the executives who are like going to get fired if something really bad happens in the company really want certain things to hold. And so for them, soundness makes them really happy. And I guess the point I'm making is, I wouldn't have known that if we had spend a long time trying to make our tool perfect. What we did is we launched a bunch of tools, put it in the hands of customers, got them using it, went and talked to them, went and talked to their leaders, and then we began to hear themes that taught me things, which then influenced what we were building later. Okay, yeah, so this is an amazing quote. I'm not going to name the bank, but we're going to move orders of magnitude workload over to AWS because of this work about formal methods, proofs of crypto. That really got the attention of the leadership of Amazon. Very early on this happened. Amazingly, it was because they knew my PhD advisor. I think the 6th or 7th week as an AWS, I went to lunch with some major bank with the salespeople, and someone there had worked in DARPA and knew John Launchbury, who's my advisor, and then suddenly they were like, this is amazing work, let's, and they wrote to the CEO and was like, I've just met with Byron, this work is super important. Okay, so last one, let's talk about the leadership principles. Okay, so the leadership principles, so Amazon has this idea of leadership principles. You can go find them, go to amazon.jobs principles. You can Google them, Google Amazon leadership principles. And it cannot be overstated how much they are the DNA of the company. The company runs on the leadership principles. Everything else is up for grabs, but the leadership principles this is the company. It really is the company. It's hard to overstate that. And so there's 14 of them now. This is one of them. I'm just giving you an idea. They're just in natural language English. So this one is, it's called bias for action. And the idea is that it's better to move fast, right? So there's this idea of, can we make this decision quicker even though it might not work out for us? And what are the consequences of making a bad decision? If the consequences aren't that bad, let's not overthink this, let's just move. And so and what they want to do is they want to push this decision making as deeply in the organization as possible, such that the organization naturally sort of self-assembles and solves problems in the right way. So it's basically non-blocking concurrency for humans, right? It's like, you went and did that thing, you didn't check in with me, but you thought it through, and you realized that if I hated what you were doing, you could just undo it. Great, thank you very much. Rather than booking time with me and trying to run all this by me, just make it, and that's how the organization scales. Okay, so the idea, the interviews are based on them, the promotions are based on them, the performance management, everything. I hear them mentioned hourly. And the idea is that we're trying to make every human and every little team as autonomous as possible, right? So every one of these little businesses is trying to make decisions without coordinating too much with each other. So really it's a big distributed system with eventual consistency across the organization, if you will. Now, why am I, here we have a symbol, how many people are here, we think? I don't know, 200 people or something. Why am I telling you this when you're formal methods nerds? There's a very important consequence if you're applying formal methods here. So let me explain. For those of you who are relatively young, you're going to live through the following experience. You have a tool, you're a formal methods person, you go to someone who doesn't understand formal methods and you say, hey, shouldn't we be using formal methods? And you're going to get a series of responses. One of them will be just like, there's a recording, so I won't say what they normally say. And at most, in my experience, in most organizations, if that's the answer you get, you're done. You can try escalating to their boss. You can go to their boss and be like, that person was not very nice. And maybe that boss will get them to do what you wanted them to do, but I guarantee you it's not going to go very well because they're going to make sure it doesn't go very well. Right? They're not aligned. You're not in agreement. They don't agree. So they're just being forced to do something they don't want to do, and that will never work. You need them to want it. So we've got to get them over the line where this isn't their response. And you don't have tools at a lot of the other places I've worked, but at Amazon you do. So at Amazon, we're customer obsessed, right? So leaders start with customers and work backwards. They work vigorously to earn and keep customer trust, right? Although we pay attention to competitors, we obsess over customers. And so you can subtly remind them, but that, customers want this. And so they will be trained, if they aren't, they're going to be not at Amazon very long. They will be trained to ask, okay, but tell me more about the customer need. and see what just happened. They, you know, any other company that said, get off my turf, you're kind of done. Now we're to step 2. Like we may not get there, and we may not get there for a long time, but we're still in dialogue. We're having an adult conversation, right? Is there customer need? How much would they pay? Tell me about the market segments. What's the minimum viable feature we would need to make this a success? All these kinds of things. And what I see really frequently is people, this is the discussion we'll have, and we walk away friends. We're like, that's great. Here's my list of priorities. Here's you. So we're not going to prioritize you right now. But I get it. I see this as important. I can see there's customer need, but I'm not going to prioritize it right now. Great. So I go off and do my thing. And then 6 months later, they have a really bad day. Like a security event or something really horrible happens. And they call. And they're like, my prioritization has just changed. I'm now quite interested in talking about your formal methods tool. We have a meeting with the leadership on Friday to talk about how we're not going to be in this situation again. And I would love it if you came and explained all that formal method stuff that you were talking about that I didn't understand at the time. And this has just happened over and over and over and over. This is literally how we grew automated reasoning in Amazon. It's you go, they say no, you use this trick, you kind of get into their heads what's possible, you leave, you wait, and you have a bunch of fishing poles out and you just chill and wait for them to call you. Another one you get is, I don't get it. Right? Oh, but at Amazon where you learn and be curious. Right? You get the idea, right? So, okay, are there any tutorials on it? You know, what tools are easy to use? How much do they cost to run? How hard is it to hire? I don't understand these tools. Could you find some friends of yours? Well, yes, I can. And same thing, right? So, and that's kind of the idea. That everyone at Amazon, for the most part, I mean, there's a few people that aren't, but for the most part, people are pretty strong on these. And so basically, you can get into any meeting. I'm in meetings all the time with people I've never met, and I know they're going to be strong on these leadership principles, and thus, this is how we can operate. So I'll just a few more. I won't go into quite as much detail, right? Can't we get away with less? But we insist on the highest standards at Amazon, right? No one else does this. Why should we care? But we think big. People usually don't notice that there's a bug. But at Amazon, we earn trust. Okay, so that's the idea. So the leadership principles make collaboration possible and productive and fun, frankly fun. I have deep friendships across the organization. There's no us versus them kind of stuff going on like I've seen in other companies. So it's pretty amazing. So I think that sort of belabors the point. So good, I'm doing good for time. So yeah, so the point was I wanted to tell you about kind of why I think Amazon has figured some stuff out, and maybe some of these ideas will influence how you run your lab or how you run your company, or maybe some ideas if you're in a large company to help the company introduce some cultural changes. I think it's really important. I'll close just with one slide of open challenges. So I just told you about how important soundness is. So there's good news and there's bad news. So the good news is the Amazon leadership totally gets soundness. They're so into it. The bad news is sometimes the tools are unsound, right? And so I've had some really bad days when that's been true. I remember one in particular where the head of EC2 wrote to me and my boss saying, hey, we found this bug in this code. I thought you guys proved it. And we had to dig in, and it's like, oh, well, it turns out they didn't have CI/CD turned on, so they weren't continuing to do the proof, first of all. Secondly, we did a proof of some C code, but now they're talking about Rust code, so it must actually be different code. And it worked out, but we have definitely there have been some bugs in tools that we all know and use that have made it such that I was in meetings I really didn't want to be in. Another issue is tool predictability. So it turns out that if you make a tool that usually works, and then you make your graph for your paper and you submit it to PLDI and you get in and you're like, yay, that's not quite the same experience as if you're a development team with a bunch of developers who don't know about formal methods. They write their code in Daphne, they write their code in SumProver, and it was working yesterday, and then they changed a few variable names, and now the proof isn't going through. That's a really bad day for them. So that's this proof instability. It's something we've been working on quite a bit, but it's tricky. Another one is these tools are really hard to use currently. There's sort of a spectrum. Automated reasoning is actually a terrible name for our tools because they're very far from automated often. So kind of what I'm seeing, and I think a lot of other people are seeing right now, is that LLMs may change things around a little bit, but we're relatively hopeful there. But if you're looking for research areas and you want to have a big impact, one thing you could do is make the tools really usable. One really inspiring example of this is Rust. Like if you think about it, if you're doing Rust, you're kind of doing a proof, but you don't know it. And a lot of people don't think about it that way, but you are. The borrow checker is a prover. But the error messages are amazing. So I remember I spent years trying to get the EC2 team to use various tools for proving the correctness of C, like check C, for example. And they always found like 1,000 reasons why it wouldn't work. And then one day, they're just using Rust, and I didn't even suggest it. So they got something right. Proof maintainability is a big issue. So we do these proofs, and they're really complicated, and we have really smart people working on them, and then they go do something else, and then about a year later, we get a call, and it's like, we made some changes, the proof broke, can you help us? And then we're like, have totally context switch out that proof. That's pretty tricky. Competitions kind of don't incentivize the right thing. Hey, Team X, could you add this feature that's super meaningful to us and would like make the world more secure? No, I can't, because then I would lose the competition. Well, that's not quite the right thing, is it? So I kind of get the value of these competitions, like StatComp and SMTComp, et cetera, but they kind of drive, like, I'll give you a really great example. The reason, I think, that there hasn't been a lot of research in distributed or parallel proving is that the competitions, out of the gate, say, you have this limited resource. And they'll say you can't store lemmas. Well, that's like totally the wrong decision. If you think about it, like if you can prove something and store it, like imagine you like compute all the automata complements for string reasoning and brown out a whole data center for a week to compute them, but then store them somewhere, and you can reuse those. Why would you not do that? But that's not allowed in the competition, so thus no one's working on it. So I don't think the competitions are like, they're great, but they're not always incentivizing the right thing. So it's something to consider. And then of course, we need a lot more people in the space. So AWS is trying to hire in the space, but also so are AWS's customers. And so are a lot of other companies in the space. So we need more people. And so one of the things I'm seeing in the US is we hire someone from a university, and then the department head replaces that person with an ML person. And so that's kind of bad for us, right? So I'm kind of afraid to hire too many academics because like we're actually reducing the number of people teaching in the space right now in the US. I don't know, Jeanette, if you agree that that's happening, but that's, so I'm trying to convince a different department. So the problem is a lot of department heads don't know about the success of this work. They know about machine learning work, but they don't know about the success of this work. And so they don't realize that this is kind of what I believe to be an up-and-coming area. Okay, so that's it. We've got 10 minutes for questions. I'll just leave. We are hiring. So if you're a PhD student and you want to do an internship for 12 weeks, let us know. And then we're hiring scientists and engineers too, and this is the right person to write to about that. So thank you very much. There's microphones, I think, so probably hold up your hand.
Okay. Do we have questions?
One microphone is enough to.
Okay.
Should be working. Hello?
Yeah, brilliant. Thank you, Byron, for one talk that I thoroughly enjoyed. Let me challenge you on your ladder, I guess.
So I guess you knew this was coming, right? So I get your rationale
That you are people that the research truly matters, taking a step that they appreciate, fires them up in terms of being excited so that you can do more. Okay, but that's not going to get you to the moon because climbing up the ladder is closer to the moon is still the wrong way. So I guess my question to you, what should the academic community and the research industry do together to make sure that while they're benefiting from those positive feedback cycles, they're also not losing sight of the rocket building? Yes, now it's too late. Should I ask again?
Let me active listen back to you for the benefit of those who heard every third word. As usual, I've made a point that's too extreme. I'm kind of making it a big point.
And so I pulled that on it. And
The point is, so there's an idea of the fox and the hedgehog. Who's that? Anyways, I know about it from, there's this book called On Grand Strategy. And I learned about this concept from there, but it comes from someone before. The idea of the fox and the hedgehog is the fox is super clever and always changing directions, always very clever, but it kind of never gets anywhere. But it's always changing direction. The hedgehog is like, right, like they go in this direction, they can't revert. And neither extreme works. If you're a fox, you're just kind of always like changing position because of the kind of current situation you're in, you're not going to get somewhere. But if you only go due north, you're going to get stuck in a swamp, something's going to go wrong. You have to kind of be a bit of both. And so I guess what I'm saying is that I've always, like, if you look at when I worked at Prover.com, right, I was working on the same thing I'm working on now. I'm going to do formal methods to the day I got it. I'm always going to do it. That's what I do. But what Amazon has done is it has pulled me out of my comfort zone and forced me very much against my will on some of these things. And what I'm saying is I've come back to report that it kind of worked and they were kind of right. I don't really like it either, but they're kind of right. And so I think you need to have balance between them. So, yeah, so don't, please, folks who are young, don't over-index on what I'm saying. I'm saying, like, you know, if you've chosen formal methods as your career, you're probably a stubborn person. And so you're naturally got the right intuition there. And I'm just saying, find a bit of balance.
Awesome. Yeah, thanks a lot for the talk. Super interesting. You mentioned some of the challenges, but have you found a specific part at Amazon where you've tried to apply formal methods and you've just failed? And I would be like interested to hear in like 1 or 2 examples, if you can share those.
The 2 reasons that they fail are that the tools didn't scale the problem, and the other is that they didn't really need the problem solved ever. So I'll give you 2 examples. One is when I first joined Amazon, Michael Hauschnick joined, and maybe it's just Michael, maybe 1 or 2 other people. Actually, some of them might be keeping interns in this group, but we decided we were going to prove the correctness of the hypervisor. The hypervisor was being written in C, and we're like, great, we have tools for that, no problem, right? And yeah, it turns out big problem. And it totally didn't work, and we failed. What's really amazing is that the culture of Amazon allows you to fail and to learn. So the same people that we failed with several years later came back to us and said, let's take another swing at it. How can we do this differently? Like, if we were to rewrite the hypervisor again, because we're rewriting it again, how would we write it such that we could do this proof? And actually, could you help us build it at the same time? And so that's kind of what's happening right now. There is a project that we're building hypervisor infrastructure and doing proofs.
And that's one example.
The other example is sometimes the door opens a little too easily, right? And so someone will come along and they're like, we need formal methods. And I'm like, great, you said you want formal methods, I have formal methods.
And
we kind of
like build a team, we do a bunch of
stuff, and then it kind of turns out
they didn't need it.
Like no one cares. And then, you know, things kind of truck along for a while. And then the leadership, maybe there's like a war in Ukraine starts, for example, and then like the economy changes, and then suddenly everyone's kind of like double checking that they really need to be doing everything that they're doing. And those times are kind of rough for the teams that kind of won't work out.
Any more questions?
Thank you for this great talk. My question, actually, I have a comment. So and the question. So if you were to, if you were to give this talk from a different perspective, like applying formal method in the safety critical domain, I guess it would change in some of the statements that you put forward, isn't it? Because I'm thinking like the verification focus is different. In Amazon, it's like first, it's mostly about distributed state, consistency, algorithms, I don't know, these kind of things. And you are subject to regulatory standards probably from the data privacy point of view, but not formal safety standards. Safety regulatory standards, which are critical in safety critical domains. So then where you need to actually check low-level real-time behavior and timing guarantees and functional guarantees are.
So we're actually, not quite. So we do formal verification of chips. We build our own chips, ARM-based chips, they're called Graphicon. We do formal verification of like the actual networking gear. We do formal verification of KMS, distributed protocol. We're doing a lot of proof of like really low-level C code. So for example, the crypto, we're rewriting the ARM instruction sequences for the tight loops like in TLS to get performance. So we're kind of doing it all. But hidden in your question or your statement there's a kernel of something really important that I want to draw out actually. So a lot of well, not a lot. There are customers running safety critical things, ton of regulated workloads. But I didn't really go after them. What we did instead was, so I was in the first person it was really funny. So I used to work for Jeanette, right? And so then I left Jeanette and I went to go work at Amazon and I reported to the Chief Information Security Officer, who basically, he didn't quite say it this way in the talk recorded, so be careful, but he basically said, great, I have no idea what you do. I guess we'll figure out if it works. Right? And whereas Jeanette was like deeply supportive of my field, and it was a totally different scenario. So I basically didn't have that much run on kind of what I worked out in that state. So, but what I did have access to was all the security incidents. So I wrote like Python code that went over and did like word searches over all the security incidents to like look for like themes. And I saw some themes. And there were 4 themes I decided to go after. So I went back to them and I said, I'm going to hire 4 of my friends, and we're going to put each of those friends on each of these things. And then if even one of them works out for a success, go for it. So then that's what I did. And so kind of to your comment, like we were kind of just going after anything that works. We didn't need to establish anything. And then what happened is that the security assessed, governments and financial services and these kinds of companies were like, that's super cool. We're about to add a big 0 to our check that we're sending to Amazon, and this work makes us feel super comfortable. So we're going to add an extra 0 because of it. Right? And that was the kind of thing. So then the AWS leaders, and then we built trust with them. Sorry, this is a really rambling answer. Sorry. We built trust with them, and then the most amazing thing happened. That there were a couple customers who were like, "We're leaving AWS because we're upset about this thing." And they're like, "Let's have you talk to Byron." And I would talk to them and be like, "Why are you upset?" Like, because we can't understand the policy. You don't even understand the policy, right? And it was like, "Well, actually, we're formalizing it, and we're going to understand it." Like, oh, that's super interesting. And so then they were like, rather than leaving AWS, we're going to put more workload on AWS. And that got everyone's attention, because this was like a major, major customer. Like this would have been like New York Times front page kind of stuff, right? And so then, so that's really, so now we're starting to hit this thing. So kind of in your comment was, hey, we're going to put this spacecraft in the air, or we're trying to get like some government authority to agree this thing can go in the air. And that's kind of a different situation than what we've done. So our thing has been more organic growth.
We still have time for more questions.
For a great talk. One is about the first part. So you said we start with this press release, and that kind of like it's the end goal, and then you work backwards from that. But of course, it can also happen that maybe you come up with a press release or something that turns out cannot really be done, or maybe simply can be done, but it takes too long, right? So how do you avoid things like cost fallacies and this kind of stuff? So
the reality is in Amazon, it happens all the time. At Amazon, this happens all the time. You read these press releases from teams, and you're like, how am I going to do that? And they have no idea. So working backwards, as we know from small model checking, often working backwards and forwards at the same time has some benefits, right? So it's kind of the same idea. So, but the things that they're doing, this is kind of to the first question. They know your tech obsessed. Like your brain is wired to go from technology, and if you're like, I have a technology. Like I studied this in my PhD in like 1995. It's now 2024. I'm here to solve your problem with the same technology, right? So it's totally technical stuff. So what they're trying to do is they're trying to push against that. So it's don't over-index. Like Amazon pushes that idea super hard because they know that everyone who's in tech kind of has a different perspective. And so it's actually balanced. But definitely it happens all the time. The customers are saying things, the product managers are like, great, I'll write a PRFAQ and start shopping that around. Everyone's super excited. And then I get pulled in, or some engineering person gets pulled in. It's like, explain to me how we're going to do this, right? That's pretty common.
We have time for one more question. All right.
So I'm an academic researcher, but who occasionally works with industry trying to persuade them to use my tools or our tools. My experience is one of the most difficult parts is getting software engineers to construct good abstractions. So I'd like to hear about your experience in AWS of that and how you, to what extent it's a problem, how you address it.
It's sort of like climbing a peak where you kind of need to get to base camp first. So often, I'll see what we want to prove, but I don't go for it because precisely to your point, that to actually do that, we're going to need to do a bunch of things and they're not ready for it. So we kind of find something else that's going more achievable that we need to first do, and then they're like, oh wow, and so like they're dazzled just by the like, I don't know, it's like a child, a small child that's given a gift and they're more interested in the box kind of thing. They're like, wow, this is so cool. I'm like, no, that's not what we're going to do. We can do much more if they don't get it right. But now you kind of build trust with them. And then they begin to ask questions around, well, how do we do this and how do we do that? And you kind of, it takes time. But ultimately, what we've seen in AWS is we just totally take over the organization. So pretty soon, a lot of people in the organizations are problem people. And that's kind of what's happened in identity, for example, and some pieces of storage and crypto, is that the people doing the work are problem people. It's like Rod Chapman, for example, crypto work, and he's like one of the most senior, respected people for just crypto things now. But he can do that. So yeah, it's a super challenging problem. The answer is the answer is it's hard to work. Hire well.
All
Do
right.
a job.
All right. I think we had time. Let's thank the speaker again.
So thanks a lot for the very nice talk, Byron. As we have again a memento from the conference. I mentioned it this morning. It's actually a design item designed by one of Polytechnico's alumni. It's actually a corkscrew. I don't know if, but it's actually a famous design item called Anna G. Actually, so you might. We hope you like it as a memento from the conference. Thanks a lot for the talk.